Okay, in this video I want to talk about what happens if my functions give me a region where it doesn't make sense to use vertical rectangles anymore. So what I mean by that is I always need, when I make my rectangles, I need them to be always defined by one of the functions on top and the other function on bottom. Or in the case of the last video, I could separate it out and I still always have one on top of the other for each specific region. Well, the problem here is that for most of the time it works at making those vertical rectangles, but over here I end up with a rectangle where it's defined on top and on bottom with the same function, and I can't have that happen. So in some cases it's going to make more sense to make the rectangles be oriented horizontally, and if I look at it this way, and I always think about this as a horizontal rectangle, I'm always going to have this blue line defining the right of the rectangle and the red curve defining the left part of the rectangle. So no matter where you're at, that's what you're always going to have. And so if your rectangles need to be oriented horizontally like that, you need to make sure that the functions are written in terms of y. Okay, so you want it written for x in terms of y, and we're going to integrate the same way, find the same area. It's just that our functions need to be in terms of y, and we're going to integrate with respect to y instead of x. So given these two functions that I have, y equals x minus 1, that's the blue line. What I want to do is I want to solve for x. So this is going to be x equals y plus 1. I'm going to do the same thing over here. I'm going to solve this for x, so I would subtract 6 and divide by 2, and so x would be 1/2 y squared minus 3. Okay, 1/2 y squared minus 3. And so now I have them written in terms of x, written for x, sorry, in terms of y, and I can go ahead and set up my integral. So the other thing is this. So when I'm stacking my rectangles horizontally, I want to think of it as stacking it from a y value to another y value. So I'm not stacking from an x to an x, I'm stacking from a y to a y. Now, again, we might have to try to find intersection points. If the graph is already given, we can see the intersection points. But I'm going to be going from y equals -2 to y equals 4 on this problem. Not from x equals -3 to x equals 5, okay, which is where the endpoints of this are at. I cannot do that because I'm thinking about my rectangles stacking, and they're stacking vertically from a y value to another y value. Okay, and then the second thing is when we have our vertical rectangles, it's always top function minus bottom, and for these it's always going to be the rightmost function minus the leftmost function. So I'm going to have my right function will be the line y plus 1, and I'm going to subtract from that the left function, which is 1/2 y squared minus 3. And so there we have the integral set up. This would be a case where I'd want to simplify this a little bit before I actually integrate, so I'm going to keep writing my integral sign. I would distribute this negative, and then as I'm doing that, I'm also going to write these in the correct order. So I'm going to have -1/2 y squared plus y, and then let's see, if I subtract -3 is going to give me +3, plus the 1 will give me +4. And I wrote dx up there, which is not correct. This should be dy because my functions are in terms of y. And so now I've got it simplified, and now I can go ahead and integrate. And when we integrate, let's see, this will be y to the third, and I would multiply by 1/3, which is going to make this a -1/6, plus 1/2 y squared plus 4y, and I'm going to evaluate from -2 to 4. So I'm going to plug in 4, and I'm going to subtract what I get when I plug in -2. Okay, so then it just comes down to being able to work through this and evaluate. So 4 cubed, 64. 64 times -1/6. I'm just going to leave that as, let's go ahead and reduce it down to -32/3 anyway. So I've got -32/3, 4 squared to be 16, times a half will be 8, and then 4 times 4 is going to give me 16. I've got that minus, let's see, -2 cubed is going to be -8 times -1/6, it would be +8/6 or 4/3. -2 squared will be 4, times a half will be 2, and 4 times -2 is going to be -8. Okay, so my advice when evaluating this is, well, first of all, I want to distribute this negative, but you should be able to kind of do that at the same time. What I would do is combine all the whole numbers, combine the fractions, and then if I need to, then combine those two things. So let's see, this is going to turn this into, let's see, I've got 8 and 16, 24, minus 2 takes me to 22, and then plus 8 will take me to 30, and I've got -32/3 minus 4/3, which would be minus 36/3, and 36/3 is 12, so I get 30 minus 12, which is 18. That's the reason I would do that. So sometimes you'll see people automatically, if they see a fraction in here, put everything in terms of thirds, so everything over 3. But you don't want to do that because you might end up with something, and just combining those like parts together, you might get something that simplifies, makes it a lot easier. So, so this is an example of some rectangles being oriented horizontally. I evaluate the integral in terms of y's, but it's pretty much the same thing as the example before with x's. I just need to make sure that I can see which way the rectangles need to be oriented.